I'm Professor Caudill. So today it'll be a little limited because my keyboard kind of died from a power surge. So we'll do the best we can. So this chapter has been really hard for me. I think last time I complained how this is a vector and then it's talking about a constant. So here they're talking about a magnitude of tau or the torque. And this is in joules or newtons times meters, newtons per meter. So they're talking about corkscrew rule, two vectors, cross product of them. So they're defining the cross product as two magnitudes times the angle in between, and then it give you a vector on in the whole different direction. So mechanic problems, we often do not use the corkscrew rule at all. We'll see the following equivalent solution. So if we just already identify it as on the z-axis, which is this k, so we have to make sure we have r. So we have r, and we have f. So this is our phi, angle phi, and we're hoping to calculate some vector. RF. So this is what we're trying to do. And they're arguing, so I think it's the angle. I'm not sure. I wish they had added parentheses. Because are they saying, I mean, I guess it doesn't matter. So yeah, so this expresses it as a whole vector. So R, if you're talking about the magnitude of RF, so magnitude then that is the multiplied magnitudes of each times the sine of this angle. So, and that would be times k hat. No, but if you're talking about the actual vector itself, RF sine phi times k hat. So this k hat gives it a direction. So following this principle, RF sine 40 degrees is 32. So Newton meters in the k direction. So it wants us to use 213. I'm sorry. Give me 1 second. I will fix this. Okay. We're looking for 213. Figure 213. I wish the book would just make a new figure. I know they're trying to save space, but it's kind of annoying having to scroll. I mean, all the way to the beginning of the chapter. Okay. 213. Here we are. Okay. So find and C cross F. All right. So A is 10. B is 7. The magnitudes are that. So I think phi is the angle in between. So it would be so B is measured 250 degrees, so it must be 250 degrees minus 35 degrees. Okay. Okay, and like this was the original vector. This is B. I'm guessing the angle is B angle B minus angle A is phi. Okay. So AB would be 10 times 7 sine okay. So that would be your answer. I guess you could write K as well, specify the direction. Okay, C times F. So the magnitude is 8. F magnitude is 20. So angle F minus is 110 minus 30 equals 80. So 8 times 20 sine 8 pi over 18 k hat. Okay, that's my answer. So dot product has the distributive property. All right, I think we covered a little bit of this last time. I think last time I showed that if j hat is k hat times I hat, using the rules of the algebra for this, it would have to be negative I hat times k hat. If you wanted to swap it for some reason. Okay, so in another sense, when you're taking A times B, um, you're, so A times B, both have a plane. Okay, so let me write this down. So if you have a vector A and vector B, and they're both on one plane, okay, so that means they each have an I. Each vector, okay, so uh, A is the magnitude of A in the x direction times I hat plus the y magnitude times j hat. And same for B. So A cross B is, um, there might be an interaction with I times I or I times j. I times j, where you get some k hat. Okay, so they have this proof. So some universities you might just sit in a lecture and you might just have to watch a professor write this proof down. We're not going to do that necessarily, but we can look at it and see what sticks out. So A cross B is if it's in 3 dimensions, it could be more the dimensions, it could just be 2 dimensions or 1 dimension. But in physics, 3 dimension is most intuitive. So you have the components of the vector times the components of the other vector. Okay, next step, they're taking AI times B. So if it's, let me just write this first line. So they're taking this and they're distributing it. A cross this. Okay, and then they're taking this whole thing and they're taking this. So it's AI cross all of this. AI, or the J part times all of this, and the Z part times all of this. Okay, so you're going to get A cross this. Okay, and then this turns into 3 lines. Um, so the first line would be EXI and then you're going to continue this process by doing for each element. So you're going to get AX, BX, I cross J, dot, dot, dot. And we know that has to be A, X, B, X, K hat, given the previous rules. They're getting 0. So there's a rule I'm missing that makes this 0. So we need to know why these is 0. Okay. Are these I's? These are I's. So this is actually a J. So equals 0. Okay. So when you cross unit vectors, you get 0. But so yeah, that's just the rule, I guess. So, but if you will see when you get to AX, BY, the I component of the A part cross the J part. So yeah, so I just miswrote this, but this next part is going to be ax b y, I times j is going to be k. Okay. Now, what I want to know is why is I times I dot I cross k negative j. So if it's positive k here, why is it negative j here? I'm guessing it has to do with these. So we are taking I cross j, I cross k, I cross k. If j equals k cross I, and I want this to be expressed as so this is the same thing as j negative I cross k, then it's not making sense. I cross k here should be j, jk. We're taking I times I cross k. So none of these are I cross k. So, but we know j can be I cross k. So if we divide by 1, negative j hat could be I. I don't know if I can do that actually. It is saying, okay, so here is the rule. Here's one example. If you have I cross k, you get it in the different direction. Okay. So then negative I must be k cross j, which would be something like that. Looking at this B section here. Okay, so there's a lot to this, a lot of algebra rules. So then you group them AY BZ minus AZ BYI. So I think they pulled out the J. You can distribute this negative sign on the J to AX BZ. So all the vectors, unit vectors are positive. So in other books that I have seen, they will argue the cross product. So A cross B, where equals, so if you're taking A1, A2. If you're taking a list of numbers cross another list of numbers, another textbook would say it is the sum of A I times B K, where I is 1, K starts at 2, and then you have to like, I don't know how to write it, but let's say you have to like sequence it. You have to like uh let me just spell it out. So it's going to be A1, A2, A3 cross B1, B2, B3. So it's going to be this plus this, and then this plus this, this plus this. If that makes sense. So A cross B is going to be A1, B2 plus A2, B3 plus A3, B1. So if you can see, is equals to CX plus CY plus CZ. So that's how I have learned it in another textbook for reference. So it looks like if you wanted to write it another way, how could we draw this? AXA. I don't know if that's totally correct. Now this is in 2 dimensions. No, this is in 3 dimensions. So if I change these to x's, so if this might be described as ax by plus ay bc plus az bx. I wonder if that would make sense. Okay, so I see AZBX. This might be your CY. AYBZ might be your CX. This is just rough, very speculative, but AXBY might be your CZ. Might be. Okay. Particle in a magnetic field. When moving in a magnetic field, so what's a magnetic field? It's a bunch of arrows that have a force. So we have a magnetic field. Some might describe this as maybe a phase a phase field, but I'm not 100% sure on that. But let's say this is our magnetic field. So we're going to say this is vector B. Mag field. Mag force equals F. B particle magnetic force. Okay, so the magnetic force vector so F equals some proportional thing times this. So I wonder if it's like this or if it's this. Book does not really make it clear. This is positive. Okay. So particle moving in space. Okay, so let's say U is so let's say particle moving in space. So we have a particle moving this fast, enters a region, enters my field. Okay. What's the force on this particle? So what force, what is this? What is this force that it hits when so it's getting a force from a completely different direction. So that's why we are using the cross product here. Find the force, so this is F. We want to find F on U. Okay. Find the magnitude F. Okay. Find the magnitude of F. So we want to Find f of f. Find angle f and b. Okay, so there's a lot here. First, we want to find the product vector u times v. So before I read further, let's see if we can do it ourselves. So first, why would we find this? Why find u times b? Well, it's, first of all, it's here. So guessing we would draw this like this. So we know u, we know b, so let's find u times b. So that has to be u b, the magnitudes, times the sine of the angle in between. Okay. All right, so what's the magnitude of u? U must be Pythagoras theorem plus 2 squared plus 3.5 squared. Okay, and B must be okay, so these are our magnitudes, and we want to find the angle between A and B. So I wonder if we can do, nothing's coming to my head for an easy way to find the angle between A and B. So angle of B and U equals phi. I'm not sure how to figure this out, so let's see if the book helps us. Okay, so one can't find the angle from the dot product. Okay, I remember this equation, cosine -1 u dot b u times b. I think that's the angle just from my head. So we know u dot b is, oh man, what did the book use? I think of it like a sum of each component, but I think the book did it some, did the book do a b, maybe cosine? No, that's not right. All right, I'm gonna guess that it is -5 plus 7.2. No. -5 times 7.2 plus 2 times -1 plus 3.5 -2.4. Okay. Let's see if I can do this. Okay, so we have -5. Very tedious without the keyboard. So cell run. Okay. I'm getting -46.4. So, all right. Let's go up here. We have -5, 2. Okay. So I'm thinking theta is cosine -1 of -46.4 divided by 6.4 times 7.2 times -1 and -2.4. 7 point. Okay. -46.4 divided by 6.4 times 7.7, and we want to take cosine. Okay, 2.9. Do I need to convert this? Uh, Okay, that's not right. Uh, okay, 160 degrees. So I'm guessing it's 160 degrees. Final answer. All right, that was a very tedious calculation. Show me 160 degrees. No. That sucks. Okay, so we're off. Let's see what we did wrong. Okay, so the book's just copying this pattern from here. So I don't know. I think that's kind of cheating because, like, who's gonna remember that? Man, I do not know how to draw this. That. So who's gonna remember this? Um, um, so I think it's saying U cross B is okay. So we remember the dot product, right? Um, so we have the components UX, UY, UZ. It really just comes down to knowing what I've written here. They've taken this from the above where it was CX is. So I, I want to build intuition for this. So if we have A, let's say A is A1, A. So this is our vector. It is, if you know how to multiply two vectors, this is equal to AXI plus AYJ plus AZK. Okay, so that's our vector, and it's saying the cross product is going to be AY times BC. So if B is like that, then So it would be cross this. I think it would just be multiplied by this as well. All right, so the book is saying AY. So C equals A times cross B, which is saying, another way of saying CXI CYJ plus CZK. So when you do the cross product, you have to multiply by the vector ijk to get the directions, because the cross product itself is just a number or a sum of the components. It's not, doesn't have a direction itself. Or I should say, so these are vectors with a direction. So it's really going to be I, J. The A is going to have its own ijk vector, and B will have its own ijk vector. So when you multiply these, when you multiply these, it's going to be I squared. I think I squared is 1. I cross I. I'm not sure if you multiply these, take the dot product. I don't think there. I don't think it would have to be dot product, right? So it'd have to be I squared, which is 1. Or maybe it would have to be the dot product, which would be just reordered. If it's cross, that'd be ij, which would be k. jk would be I. So when you take the unit vectors, cross themselves, you just get, so I, J, K, cross, I, J, K, it's going to be I times J. So 1, so it's going to be 10 times 0, 10. Okay, so let me get back to what I was doing. Maybe I'm getting too far off on a tangent. I want to prove the book's doing. So A So the CX is going to be AY times BZ minus subtracting AZBY. Okay. So over here, similarly, it would be CY. Okay, so CY is AZBX. So if you imagined this continued, so where these are the same values, and this is just a repeat sign, just for notation purposes. So I think my original cross product notation had the first cross right, but I missed I didn't remember the subtract the opposite direction. So CY should be AZ BX minus this. So CY should be AZ BX minus AX BZ. Is that what the book got? AZBX AXBZ. Okay. And then CZ is going to be, just drop down, it's going to be this minus this. So it's going to be AXBY minus AYBX. Okay. So let's return to the problem. So we have U equals -5. We're about out of time. So U cross B equals U B sine phi. So sine phi. So another way of saying this is U B times 180 pi cosine -1 U dot B over U B. So I think that's where the sine is coming from. The sine phi. The sine is Okay. So I hope I'm correct here. And this would be in, this would convert. I don't know if I need the 180 of pi. We might not need this. It might just be UB, magnitudes of UB times the cosine -1. So the cross product might be another way of saying it's this. Or we could also say -5, -2, 3.5. Is 5 minus plus 2, no, -2 times -2.4 minus 3.5 times -1. And then plus 3.5 times 7.2, so 3.5 minus -5 times 2.4 times 2.4. So the cross product could also be described as that. So either way, so basically it's saying this is equal to the magnitude. So maybe this is why they teach the dot product before the cross product, because the dot product is in the definition of the cross product. So you could do it this way or you could do it this way. All right. Thank you guys. I'll see you next time.